please let me know. And feel free to ask questions during this talk, right? Well, welcome. Um, Today we'll talk about the event-driven architecture and a little bit about the Medcan solution and how we built it and what we did in this customer project, right? This is a very different architectural type. This is a very huge solutioning. We have replaced an integrator system called MuleSoft by this integration system built on this, based on this event-driven architecture. Just to explain a little bit about who am I. Well, I have 20 years working in the IT market. It's a long time. I am general constant for many companies and startups as well as an enterprise solutions architect. I have been a former Microsoft student partner in the past. It's quite like the MVP title for academics. I'm also a professional Microsoft speaker, so you will see many presentations at Microsoft in general in Brazil because I'm based in Brazil. For that who likes, I am also a kart driver. There's a lot of trophies around here, and I also built my own motorhome during the pandemics. And while everybody was working locked in home, I was traveling locked in my home on wheels. Well, to start this talk, we need to understand a concept that is traditionally uh, being said in the IT market, in the business market, that is, what is a digital transformation, right? We need just to know and to look to this term in the right way and at the same way, right? So the digital transformation is the adoption of a digital technology by organizations to digitalize products, services, and operations. But the goal of this type of implementation is to increase their value through the innovation, invention, customer experience, and of course, efficiency, right? There is no digital transformation if you don't have a good technology. But where's not jumping? Before the technology, the company needs to go through a lot. We need to go through some key points to be able to start our digital transformation path. We need to have a clear evolution plan, what a company does, where the company wants to go, what the company is doing. The company needs to create a culture of innovation. We need to be innovative in the bloody. Our bloody needs to run innovation. Of course, the company needs also investments in technology because there's no digital transformation without technology, right? The company needs to train and empower the team like we're doing now. The company needs to have a committed leadership, people that is looking for the right direction and making people follow the same path, the same direction, the same way of thinking. And of course, there's no digital transformation if you don't have a way to monitor and evaluate your progress. So these are some key points to go before talking about a digital transformation. But Lucas, why are you talking about business? We're supposed to talk about event-driven, right? Because we need to achieve a digital transformation in teams like with scale, right? This is what our customers are looking for, how to achieve a digital transformation. So we should know what they are thinking so we can provide the best direction, the best way of thinking, and we can help them pass through this process, right? So um, one of the ways, one way to do this digital transformation is an event-driven architecture, right? And I would like to know here, if you can talk, if you want to talk, if someone here already worked or heard about the event-driven architecture, right? And again, feel free to ask me questions during the session as many as you want. So, in fact, what is the event-driven architecture? When we go through the digital transformation and we start building large companies, in general, the company needs to work and to react to the events, to the facts that happened very quickly, right? The company wants to know almost in real time that something happened. This is how big companies become fast. This is how big companies react fast to what happened. And one way to do that is this async communication. Let's imagine something. You are sitting in your office right now. Each of you here have one responsibility. Everyone have a different role in the company, right? Now imagine someone enters the office, open the door, and screams something. If someone is talking, someone wants to listen, right? Because if you have a communication, you need to have a listener. All right. So this person that that entered our office produces a message or screams something. Let's imagine this person says, hey, we sold a new membership. Okay. This is the message that every single one in the company received. So many things will happen after a message comes in, right? So, for example, the marketing will say, okay, let's send an email to this guy. Let's congrats him. He bought a new membership. The commercial team will say, okay, let's plan the upsell. We need to sell more. This is how we drive our business, right? We need to sell. Let's plan the upsell. Let's add this person to our pipe drive or any CRM system or whatever it is. And for example, the IT guy will say, okay, I don't care. It's fine. I get your message, but I don't care, right? In general, this is the way how async communication works when we have an event-driven architecture. Everyone is reacting to that event at the same time it happens. Let's talk more technically about it. So it's quite like if you have a system, let's imagine you have a system that is producing an event in an event broker. Like, okay, someone bought a new membership, right? This goes to the event broker, and then we can start many other systems to do their job. We also can translate this image in bounded contexts. So I have one bounded context producing an event and many other bounded contexts doing their jobs independently, right? So when something happens, we send that information to the event broker and we trigger other things to happen elsewhere, right? But you can say to me, okay, Lucas, but if someone does not receive that message, and if that message fails in one of those adapters, what happens? This is the complexities of this architecture. This is the challenges, and we will see more about it in the future. So some important topics and important tips about an event-driven architecture that we need to think, and we have to we need to take this in top of mind, right? So this is a business-oriented event. We should never thinking about technology. I should never drive or design our events based on technical problems. Because again, everything here is related to business. This is the reason I started this talk explaining about the digital transformation and how the business sees those stuff and how the business wants to build up the solution, right? Another point is event always in the past. An event represents the consequence of something. Like, for example, someone bought the membership, right? Or a new account has been created, or the account has been updated, right? It's something that already happened. It's the consequence. Reason why it's always in the past. When we design, when we design the events, we need to think in dissociation. I am sending this event, and I don't know. And to me, I don't care who will receive and what will do with this information. Because one event cannot be associated with the listener, right? You will never send an event to one specific process or to one specific person. We need to think in a way that that event makes sense to the whole company. And that example represents that. Again, always imagine someone entering the office and screaming the event. I will give you another problem. Imagine that someone enters the office and say, hey, we have a new account. His name is Lucas. His password is 12345. His email is lucas.massena, blah, blah, blah. It makes sense to you? Right. Don't make sense. We cannot design our events based on the entities, based on the values that we have, because we can leak information. I will talk to that about later. Another point is scalability. Every time we design an event-driven architecture, we're talking about scale. We can receive thousands, millions, billions of events per second. We can store them for a short period of time, and we can process them after. We can scale our environment as much as we need for that specific process, and we avoid paying extra charges if we don't need to go so fast, right? This is another benefit and another way of thinking. And one important point that we need to bring to the table when we design software and architecture of this type is the resilience. We need to consider that the things can fail, and they will fail. What I mean they will fail. Again, let's imagine someone enters the office and starts screaming the message, hey, they lost the voice. For some reason, they lost the voice. So the message is incomplete. The producer of the event was not able to produce the event. We may have another problem in the listening side. Oh, go ahead, ask a question. I can't hear you if you're talking. I can't hear you. No? Okay, I will keep going. So you can have the same problem in the other end. Imagine someone is listening, is interested in listening that message, but someone's talking behind and the message getting confused, right? And you lost that message, or in the time that the message arrived, you was paying attention to something else and you lost that message. So we need to design this solutioning, talking about resilience. How do we retry? How do we keep track of those events? How do we make sure that everything has been right processed, right? We also have some anti-patterns in this type of architecture. Things that we need to consider and take care. when designing this solutioning. Like, for example, we cannot have dependent events. I cannot create an event expecting that something happens later. My responsibility should be limited to my domain, to my rules. Like, for example, I am the marketing system. If you said to me that a new account has been created, I will send an email to them. And if it's important to the business, I can create an event saying, okay, email sent. But I cannot have dependent events. We also cannot have sequential events. We cannot have things like that. Okay, here is the account. Here is the addresses of the account. Here is the orders of the account. It doesn't make sense. So creating sequential events brings a lot of problems because they are in somehow dependent events, right? Again, we cannot have events with expectations. I cannot send an event waiting for an answer. Never, because I don't know my listeners. Always think like this way. Imagine someone walking into the office and screaming a message. That person that is screaming doesn't know each of one that sit waiting for the message, right? So we cannot expect anything from the event. Another important thing is a common error, very common error in this type of architecture is generic events. I see a lot of solutions creating generic events, like, for example, account. Can you imagine? Someone enters the company and screams, account. What happened to that account? Probably you need to open the message and see, okay, this is account created. I will do something. Or you need to open the message and read, okay, this is account update. I don't care about update. But this generic event make you listen, open, and process the message to ignore it instead of selecting briefly if you want to receive that message or not, right? And in general, generic events are leaky events. What is a leaky event? Is that example I gave in the beginning of the talk, right? Imagine someone walks into the office and screams, hey, a new account, ID 123, username Lucas, password 1234. This is considered a leak because you are broadcasting sensitive information to many people and you don't know who is receiving that message. So you're leaking information, right? And this is quite a common error when people build the events based on entities. When we have entity-based events, this is what happens. We leak events because we pick the result, the entity with all the information that we have, and we send to everybody. Hey, here is all the user account information. Take care. Do whatever you need. Here is all the entities. You leaked data. Another important topic that we cannot do, is create event as commands. Remember here on top, right? If we can't have sequential events, if we cannot have dependent events, I cannot have a command as an event because a command expects something to happen and an event cannot expect something, right? And this is the last item we can discuss. People is open to discuss, and sometimes it makes sense. We cannot have an event as a method call. This is something that breaks the objective of an event-driven architecture, right? Because the event should represent the consequence of something that happens. So if you have an event that will call a method to do something, you have an event with expectation. But for some architects, for some people, you can have a method call. I personally don't like because breaks all the stuff I told you before, but this is a discussion that is in place in the community. It's not so easy, right? We're talking, if you think there's a lot to consider when we're building up this type of event, but this architecture. But there's a way, there is a facilitator that help us understand more about the business requirements, how the business works, and help us design those events. And this technique is called event storming. And one important topic, again, event storming is not about technology, right? And as Frederick von Hayek said in the past, knowledge is dispersed in the society. So what's the best way to collect the information that is dispersed in society? We need to reunite the people. We need to put them together. We need to ask that society what we need to extract information from them. And here comes in the event storming. The event storm is a way that we can formally design the business requirements, how the business works, how the business thinks, what is important in the business perspective. We're not talking about technology. We are technicals, and it's very hard in the beginning to think how this works and how to drive this type of conversation. But let's try. So Alberto Brandolini, he is Italian. He created this methodology to help generating and mapping the events. And each card have one specific rule and means something, right? So when we have a session about event storming, we need to invite the right people to the table. What I mean the right people? Let's think that we have a pizza delivery company, right? We have a pizza delivery company. So we can have the cashier, the person that is receiving the money. We have the cooker that's building the pizza. We have probably the manager that's conducting the operation of the store. We have the delivery guy, right? But why I need the delivery guy? Because he's part of the business. He's doing the job. You cannot have a success story with your customer experience if you deliver the pizza badly, or if you don't deliver, or for example, if you doesn't know if your motorboy has been hit in an accident and lost the pizza during the way, right? So maybe this is important. We need to have an unlimited modeling space. My suggestion, there is a tool very good called Miro, Miro.com. It's a good solution, unlimited board space. We can put everybody in the same room and start drawing together what is needed. In the event storming in general, we create the events organized on a timeline in a way that we can see the being executed, how long the business goes, how long the time goes, right? And the event storming is a collaborative deliberation. Everybody seated, looking to the same board, expressing their feelings, expressing their thoughts. This is what we're looking for. We need to extract from these people the business information, how the business works, how they see the business works, right? And we need to ask questions. Ask lots of questions. We need to ask how many questions we need to extract information, because we need to write a prototype. We need to draw in this unlimited modeling space what's happening with the business. And in the beginning, people get so shy, don't understand what we need to do. We need to explain many times what is an event, and it's okay, because after time, after some minutes, the ideas will come up. The business will start flowing in the table, and everybody will start talking about that requirements, right? The outcome of this meeting is the representative view of the general understanding. So everybody will say, okay, I never thought that it's important the business knows if the motorboy gets hit on an accident, right? Because we need to say to the customer, hey, had an accident with your pizza and I will send you another one later, right? So this is a little bit about event storming and how we can build up those events and understand the business. So like, for example, how do we start collecting our events? I want to ask everybody that is involved about, okay, think in what is important in your perspective about the consequences of your work. For example, the cashier will say to us, I have a new order entered. I have order submitted. Probably the manager will say, okay, I have an inventory updated because I was counting the products in the back, right? We can have, for example, oh, shopping cart has been updated. Someone added a pizza in our shopping cart. We need to start separating the items, right? So people will start expressing their thoughts about those events. In the sequence, we can start organizing these events that everybody's putting in the board. We can group them into domains. Here we have a feeling about how the boundaries of the work of the business are segregated, are separated. So everything that is related to order or money, or I don't know, is separated in a group. Everything that is related to customer is separated in another group, shipping in another group. So you can have that boundaries. We can call that a domain boundary or a bounded context, right? To who is not familiar with those terms, I invite you to read more about DDD. It's a domain-driven design, right? The domain-driven design is a technique that we think about the business requirements, how the business works, and translate their necessities into code. And we are taking advantage of some terminologies of the DDD around here, like domain, bounded contexts, all right? Well, so we collected all the events in the first step. The second step, we redefine those domain events, and then we can start tracking the causes. What happened before that event? Like, for example, I may have an inventory updated, but to have the inventory updated, what happened before, right? What should happens in the business? Who is doing something that will produce that event? Like, for example, the user entered a system. I don't know where. Okay, it's a web page. So the user entered in a web page, sent some information, and then we have the input checks performed. And we may have the check inventory event, right? Again, we can have a user producing a command, right? It's a command to accept an offer. I don't know if this is a oral command. Okay, you can accept that order. Or this is a system order. But in fact, this is the consequence, right? I can imagine a scenario like that. I don't know if you have Burger King in India, but here in Brazil, we got some coupons, paper coupons, in the Burger King, right? And you can stretch a piece of that coupon that represents one burger, for example. And you can go to the cashier and say, okay, here's my discount code. And the cashier will validate, look, and okay, this is a valid piece of paper. Discount accepted. And the life keeps going. I can imagine a situation like that, right? So this is how the event is produced. Someone's screaming that something happens, right? Well, so the third step is track the causes. It's when we understand the colors and how to draw this diagram, becomes easy to understand what's happening here inside. So you have the user, you have the screen, you have the event. That event probably will trigger a command. Elsewhere, something will start doing the job later and things like that. And in the end, the last session, the step 4, we can find the aggregates, right? The aggregates means that bounded contexts with all the details, right? What causes the consequence? Who is involved in that area? Who is the user? Who is the manager? Who is the cashier? Where should we start doing our job? We can translate this into many technical solutions. We can build up microservices. We can build up a monolith with well-defined aggregates, with well-defined boundaries, right? Here we can extract, for example, what information should I store for the order? So we can look here and understand what should the order represent in a database. But this is not related to technology. We can translate it later. This is the business representation. This is how the business is built, how the business is working, right? So this is a briefly story about the event storming and how this helps us drives and understand how the business is working, right? So someone talked or imagined that boundaries can be microservices, maybe? Someone imagined that? So when we talk about a microservice, each microservice to be a microservice needs to have their all stack independently. Each service needs to be designed to have their own database, all the contracts, all the implementations, all the tasks, and all the things in one place. If you have a software sharing the database with another software, this is not a microservice. This can be considered independent services, but they are not microservice because a microservice needs the whole stack to be independent. But have you ever imagined how complex it is to build up an entire solutioning with microservices? how we track the events and how we map where the events is hitting and where the failure is happening. Can you imagine that? This sounds strange, right? But this is a real Netflix diagram of their architecture based on microservices, right? If you look carefully around this diagram, you will see some red messages flowing there. This means that something failed or that something is bad. And my question is, how do we track those failures? How do we understand where they are happening and why they're happening? And more important, how do we fix them quickly? So microservices is not a silver bullet. It's very complex and is not recommended for everything. In general, in my perspective, my personal opinion, microservices should not be recommended to anyone that is not having scale problems. If your solution is not a customer-faced solution, probably you don't need a microservice, right? So in general, we can have multiple systems doing multiple jobs at the same time with their own responsibilities, their own rules, and own databases. How much it will cost? Can you imagine that? Imagine every circle, one database, one specific database. One can be running MySQL, another is running MariaDB, another one is working SQL Server, another one is working, I don't know, relational database or Redis. Redis is a database, temporary, but can be a database, right? So every application has your own database. How complex is to keep all this information synchronized? When we build event-driven architecture, we open our hands for the consistency. We have eventual consistency, which means the account has been updated on my system. I am screaming to the company, hey, account updated, which means it's updated on my database. But nothing warranties that this information will be updated in the listener. The listeners can be offline, can lose track of this event. They cannot, or they can simply decide to ignore the message, and we will have an inconsistency, right? How to deal with that? So microservices, it's quite related, but it's very complicated. And here we are, what we did in the Medcan, what we built on Medcan. What's the Medcan solution? For who never knows, I don't know if my team is around. I want to personally congrats everybody that is working in this project. We built a very huge solution in very beautiful code. People, congrats to Sharadata, congrats to Lila, congrats to Sono. You did an impressive work with the solutioning, right? Very thank you all for your effort in this project. Well, what's a Medcan solution? Medcan is an event-driven architecture. We built a solution to replace a system integrator. They had the MuleSoft working between the systems. So every time that something happens in the Salesforce, because they use the Salesforce for everything, it's the heart of the company. So every time something happens, they need to send information to other partners or even to the Ministry of Health. Medcan is the biggest hospital or clinics in Canada. They are very big and huge. So let's imagine you have a system working in the clinics around the company and even clinics from other companies, right? Every spread in all the country. And every time something changes, they need to update the system in the edge. If I change the patient data, I need to spread or I need to sync this information with the edge. So what's happening? Let me pick here my laser pointer. Here it is. So Salesforce, someone, the nurse, the receptionist, the technical, I don't know, they go to the Salesforce and change the account, right? So it produces an event, and we call this a CDC event because they can have multiple different events. But we have a CDC event. And then this event goes to the Medcan integration ingester. This is an abstraction layer. The system have just one responsibility: receiving the events from Salesforce and translating them into event-driven architecture. Because Salesforce produces to us a generic event. They just scream to us, account, and they leak information because they send the whole payload in the body, right? And we need to split and translate this message into an event-driven architecture and store in the specific topic on the service bus. So something happens, the ingester pick the message and write down in the service bus a CDC event called account changed. Okay, end of work. Ingester is done, work done, receive, translate, and write. Done, completed. Now we have a message in the queue waiting to do something, right? This message is waiting to execute something, and we can have multiple functions. For example, we have a function that will send that account changed to Workday. It's one example. We have another function that will receive that message and send the account to the Akuro system and will replicate that information to Akuro. We may have another function that will work with as a facility. We'll receive that event and update the information on as a facility. But for the business, it's important of somehow to understand when this integration happened or successfully happened. So when the account is integrated or created in the Z facility, the business wants to know, okay, so we can have another event. In this case, we call the facility created, right? And when the Z facility is created, we need to update the information on Salesforce. Every function have your own responsibility. Every function have just one responsibility. They are very simple. This is the reason they are functions, right? This is the way we built this solution. This is how we delivered a whole solution to replace a major market integration system like MuleSoft. Let me give you again another example and how easy it is to expand and to create new functionalities in this solution without breaking the existing ones. So let's imagine we have this solution in place. An event happens, goes to the ingester, we have the event account changed, we updated the account in a facility, we produced a new event. All right, but Lucas, the business is growing and we need to do something else when the account is changed. Okay, if you need to create an integration with another system now, I will just create a new function with one specific responsibility. And this function will just update the information in Akuro. Okay, we have a successful delivery built very quickly with one specific responsibility, right? But Lucas, we need to do something else after updating the account in Akuro. We need to create something, or we need to do something, but it's just after updating the account in Akuro. Okay, no problem. We produce an event that is important to you because you need to do something later, right? So when we update the account, I will produce the Akuro account updated, right? We have a new event. Again, imagine someone is entering the office and is screaming, Akuro account has been updated, right? It's important to you? Yes, it's important. Okay. What do you do? What will you do with that information? Oh, okay. Now I will update that Akuro account in another system, like tips. We need to pick that information and update on tips, right? There's an error on the diagram, but is that. So you need to update the account on tips, and you will send the information to the tips system. See, it's very easy to expand the whole solutioning. It's very easy to have very well-defined responsibilities around. If the company wants to do something else out of the solution, they have the possibility to just listen to the events and do whatever they need with that information. If a third-party system wants to, I don't know, update the account information, they can simply plug a listener to one of those queues and start doing the job, right? Sounds simple, right? I know, sounds simple. But to know about event-driven architecture and how to build up this whole solution, that is a very huge list of knowledge that we need to have to work with event-driven architecture, and worst, to work with microservices. Feel free to ask questions. Open mic.
Well,
Just talk.
Lucas, can you go back to the previous slide where we have that architecture previous to this? Yeah. So in the beginning, we were saying that the data should not be leaked. So suppose there is an update in the Salesforce for a patient data and an event is triggered that, hey, the account of the patient has been updated. So does the data of the patient is also traveling along with that event, or is there a separate mechanism to distribute that?
Awesome question. Awesome question. Thanks for a question. So I did not represent that here, but what we are flowing here is just the patient ID or some just basic information like when this event happened, right? Because the time of the event is maybe different from the message time, right? So when this event happened, basically the message contains the ID of the user, it's the base ID, right? And every function that needs extra information, they need to ask for that extra information. So for example, imagine this function update account in Akuro. They need to go to an API from Salesforce and hey, Salesforce, give me the data for this specific account. The function have your own authentication. So this function will receive just the information that they can see. Let's imagine you can have a third-party system that will receive just the ID. And that third-party system will ask to Salesforce, hey, give me this patient ID. Salesforce will look, no, I will not provide that information to you. I don't know who you are. So this is the way we build this type of architecture, right? The events just transmit the reference, and the functions or the listeners, they need to ask what information they need to work. And you can control the access to the information in the API level. That answers
Yeah.
the question?
Yeah, that answers my question. So there is another call to the APIs requesting the changes which has been done for that specific piece. Okay, thanks.
Exactly. Exactly. Perfect. Right? Because each function may need a different information. For example, to update the Akuro account, I just need the, I don't know, name, email. But to update the account in a Z facility, I need name, email, address, I don't know, membership, whatever else. So Salesforce is responsible for answering the information. Salesforce is responsible for limiting the access to that information. This is the way we don't leak. Okay? Great question. Thank you for that. Right? So going back. So list of knowledge to work with microservices. I will provide this slide deck to you later so you can take it as a reference. And feel free to ask questions. These are here are a lot of things to learn and understand, and I will have a great pleasure to help you through this study and provide more information. So something that everybody should know about Git flow, how to work with flow, how to create a feature, how to create a hotfix, how to create a bug fix, how to commit the code, right? I, in general, see people committing 30 files, 70 files, thousands of files at the same time. How to properly execute a commit, right? I will send the link and you will have some material to study and learn more about Git flow. Domain-driven design is very important to understand how to talk about the business. How do we drive our solutioning to the right domain, to create the right naming convention, to talk the same language as the business is talking, and how to translate these business requirements into code. Hexagonal architecture, it's a different way of organizing code. It's a different way of building a solution. It's a different way to think how the pieces of the infrastructure, the repositories are related and working around the core of the application or the domain of the application. CQRS, Common Query Responsibility Segregation. How we split the responsibilities. How do we build a CQRS solution? And more important, CQRS is not all the times related to, I forgot the name, infrastructure. So we can have a CQRS code connected to the same database, extract information from the same database, and with responsibility segregation, right? Important. What is domain event? Domain event is not related to the event that we produce for an event architecture. They may not be related to the business events. Naming conventions very important. See, look to the functions here. You can see a very common naming convention here. You have an account changed in many places, but they have a prefix that means from where that event is happening, where that event is produced, which context or which bounded context it represents, right? So naming convention is very important. One thing that we need to take care and is very helpful for our solutioning is not just related to microservices, but about code. It's fluent validations. How to work with fluent validations, how we can build up a validation for our domain, for our entities, for our DTOs. Why we should stop throwing. Carefully listen this message, guys, please. Really pay attention. Stop throwing exceptions. Stop throwing exceptions. Exceptions is the worst thing in the .NET framework. And exceptions should be used only and exclusively for exceptions. If you know that something's failed, it's not an exception. You know that's failed. You know that's a failure. You know that it's a bad result. So for that, we have a result pattern, right? And we have a library called Fluent Results that help us build up a solution with less exceptions, less failures. Because every time you throw a new exception, the .NET executes a lot of reflections to track all the stack of that execution. In which class, which method, who called that method, how much time is spent in out. So it's a very big stack of information that the framework needs to collect to throw an exception, right? We need to learn more about the app insights, how to work with app insights, how to produce a log, how to inject variables in the trace, right? Observability. Let's go back in time. Imagine you have this solution working right now. How do you observe what is happening and where is happening? How do you track an event and its consequences? This is called observability. We need to have a common way to produce these events, to track the events, to track that information, right? And we need a system to monitor that and observe, right? And more important than everything, DevOps. Again, I think personally that developers should never know. Oh, go ahead.
Yes. So thanks, Lucas. This is a like great insight about all those concepts and how it is implemented in Medcan. I have a question on observability, like how it is implemented in Medcan. So if you go back to the slide where you have architecture diagram. So can you explain team and me like how observability is considered into this architecture?
No, great question. So basically, first, we don't have microservices in the solution because we don't have a database, in fact. We are just an event processor. So when something happens, we react to that event and produces a log or generate an integration with somewhere else, right? So both applications, Medcan ingester and the functions, they are connected with the app insights. And they are producing the trace events in the code. We have the log information, log debug, log error. So we can connect this stack of observability into the app insights. So for this solution in itself, we're just using app insights with all its power. And we can open, for example, let me try to open briefly. Let me try to open briefly the portal here. Let me share my screen again. So this is the board, the production board, right, in the Medcan environment right now. So we can see all the failures here, all the transactions, how many functions we have executed, the response time for each one of them, the average time for everything. If we go directly into the app insights, we can see every failure, everywhere, what's happening and why it's happening. We can also see live metrics here. So we can see the observability of the solution. So we have HTTP requests coming in, we have which function is started and where. So here we can see all the trace, right? All the information is here. We can have an application map. This is something very interesting. Here we can see the components of the solutioning and how they are connected, right? How many servers do we have, or how many instances of servers do we have, and how they are connecting. Like, for example, we have here, we have one logic app in the solutioning. I did not show this logic app because we are removing it, but we have the logic app in the solution right now that is producing an event into the service bus. This services bus is triggering our function, and the function is connecting to many other parts, like the service bus is connecting, for example, with client.medcan.com, that's a system, and many other things. So here at the App Insights portal, we can see all the tracks and all the informations that is happening inside our solution. We can also, for example, make queries, and we can track or understand what is happening with one entity. Let me try to pick here. So we can see that an entity has been executed in one part of the code, or an event, when it happens, what's the consequences of that event. So we can see all the tracks here, right? So for this solution in case, we are using all the powers of the App Insights. All right? Any other question?
No, thanks, Lucas, for that.
You're welcome. Hey, Lila, how you doing, man? You're muted, buddy.
Yeah.
If you're talking.
Sorry. So I want to say, like, we are using correlation ID to track the dependent calls of the flow. I mean, if an event is produced by Salesforce, we are tracking all the dependent calls using a correlation ID. So that I want to bring up that point. So.
Oh, great. Let me bring something important here. Let's take a look at this example, right? We got a message here, and I will say this message have ID of 1, right? This is message 1. This message will be managed by this function that will execute the job. And then we have a second message that will go to this topic. There are different messages, right? One way to create the track of the execution, that one event is started after another event, we can keep track relating the messages. So I got the message 1, I'm working, message 1, and I send this message to someone else. That person will say, okay, I'm working with the message 1, right? And if I produce a new event, I will say, okay, here's my new event, message 2. And this message 2 is related, it's correlated to this message 1. So I have message 2 associated somehow using the correlation ID with the first message. It's not necessarily a consequence, it's not necessarily a relationship, but I'm just flagging that the secondary message comes from this first message. And why this is important? Because it's the way that we can keep track about all these events. One event happens based on another event. So we trigger something based on a message. And if I forward, I will say, okay, take my event. I have changed the Z facility account because I received the message number 1. Basic. This is the objective of the correlation ID, right? Make sense, guys? All right. If we go to the log, I can search, for example, I want to see all the things that happened because of the message number 1. Or I want to see everything that happened because of the message number 2. The correlation ID should be used for that. All right? Questions? It's clear? All right, thanks, Lila. Good point to remember. Appreciate that. Go ahead, man. Open mic.
Question is on like, what is the difference between a business event and a domain event?
Oh, great question.
Yeah.
A domain event is something that happens inside the can happen inside the code. It's a more technical event, and doesn't matter, or how can I say? In some cases, it will not be exposed to the technical layer. Let's imagine I have an entity in the code, an aggregate, and this aggregate will generate a domain event that I will call account blocked. It's account blocked inside the domain of the application. So for that specific domain, account blocked matters. It's important. But the business don't care if the account has been blocked. So I will not expose that externally. So this is the difference. The domain event is important for that specific domain. It's important for that specific bounded context, right? But not necessarily should be exposed. Make sense? That answers the question?
Yeah, so we should not like send an domain event to a service bus topic at any point of time.
Not necessarily. In general, the domain event will trigger the, how can I say, the writer, right? So internally, I will say account blocked. And we can have a piece of code listening to that domain event and say, oh, account code happened. This is important to the business. Let's send to the bus. So the domain event represents a consequence of something inside the code, while the business events represent something that should be exposed. In general, one triggers another. They are quite similar, in fact, but the domain event cannot, in some cases, will not be exposed.
Got it. Thanks, Lucas.
Right? And just to finish my list of knowledge, my recommendations is the DevOps. I think that all developers need to have a knowledge about DevOps. I don't expect the developer to know all the aspects of a DevOps. I don't expect the developer to know how to implement the software in the end. but I truly believe that the developer is responsible for generating the build pipelines. The developer should know how to compile the application, to build up the application, to test the application in an automated way. So in my perspective, in the DevOps perspective, the responsibility of a developers ends when we produce the installable or the executable of the software that we're building. After that, it's the operation responsibility. Pick up that installable or pick up that executable and install in the web server and put that running in somewhere. So I truly believe that we need to have that knowledge. And I do recommend you to understand how DevOps works. And every project, every single project that we start to deliver to our customer should bring inside at least the build pipelines, right? This is my opinion. This is how I have been working the last years and how I see successful projects being released. Because we can warranty that our job that is producing a code is completely end-to-end. We build up the code, so we produce the code, we build up the code, we test the code, and we deliver the result of that pipeline. So I invite you guys to take a look in this knowledge list. There are some topics that we need to understand. I will schedule, if you want to, I can schedule more sessions to talk, and we can go deeply inside more details. We can open code here and do some demos and things like that. If you want to, just let me know, right? And one question, event-driven architecture is still simple? Is it still simple? We're still thinking the same way, right? And I will bring you one very important topic, something that you need to have in mind, right? This is a Brazilian joke. We talk this in Brazil very often. So we God we trust, everyone else must bring data. So to make the decisions, to understand what should we know, what should we do or not, I truly believe that we need to have data. And the solution needs to produce data. And based on data, we should take our decisions. Which part of the system is good? Which part of the system is not good? What's working? What's not working? And why? What should be our priority to change or update? We can only make those decisions based on data. All right? And I would like to invite you to take a look in something. Oh, sorry, I missed something. If we don't follow those patterns, if we want to go to microservices and we don't know those topics I mentioned before, this is what will happen. We will just translate one big problem into many problems. The things will keep happening in the same way. So these topics are a compilation about my experience, knowledge, and articles that I have read in the last few years, and what we're doing in many other projects, right? And here it's out of order. So I want to invite you all to take a look in this Brazilian startup. I am mentor of them. I have been working with them many years ago. They built a very huge solution for microservices and how to build and deliver code quickly and safe with the whole stack built with low code solutioning. And it's a very interesting solution. I would like to invite you to take a look on this. And they have many important trainings for free inside their platform that is covering about event-driven, domain-driven design, and hexagonal architecture, and etc., etc. So even if you don't want to use this platform as engine for building software, take a look at the trainings. They are very interesting. All right. So there is. I would like to thank you all for your time on this session. And the microphone is still open if anyone wants to talk something. Or if you want to throw some eggs as well, or tomatoes, feel free. And sorry for the quick talk and about my English. I hope I have been enough understandable, right? I would like to appreciate your time, buddies. Thanks for all the questions. And feel free to reach me out if you have any other questions, or if you want to discuss your projects, your thoughts, or talk about family or everything else. Feel free to reach me out. Thank you.
Thank you so much, Masina. It was really amazing. Though technically I wasn't able to understand much, but the way you presented it and related it with the examples, that was wonderful. And I hope it was really insightful for the team members who are here. And looking forward to conduct more sessions. As you said that you can put more insight about different topics. So I'm looking forward to that. And what I would need from your side is just share this presentation with me so that I can, share further with the team. And if anyone would like to, ask any question, they can directly reach out to you. So I'll just ensure that.
All right. I will share this slide deck after.
Okay, perfect. Thank you. Thank you so much for your time. And thank you everyone for, showing interest to be part of it. I hope this is really insightful for you.
I appreciate the audience, people. Thank you. Thank you. Thank you for all the questions, and hope to see you soon.
Thank you.
Wish
Thank
you
you,
a
Lucas.
good night, folks. Thanks. Bye-bye, folks. See you later.
Yeah, bye.